Okay guys, welcome back again. Like I said on the previous video, there's actually a total of 3 Pythagorean identity. So far, we discovered where the first one came from, sine squared theta plus cosine squared theta equals to 1. And that's built off the idea of the Pythagorean theorem, so kind of tells you why this is called a Pythagorean identity. And the idea of, if I were to draw an angle in center position on the xy axis coordinated plane, what does this all mean? So it's kind of building the relationship between the angle to the sides and to the idea of the equation of a circle. Okay, so again, some of you guys are going, why are there fractions again? Because, mathematicians are curious. So after the first identity was kind of discovered, sine squared theta plus cosine squared theta equals to 1, mathematicians couldn't help but ask themselves, I really wonder what would happen if I were to take this first Pythagorean identity and I start dividing both sides by, let's say, sine squared theta or cosine squared theta. So let's try dividing both sides by sine squared theta first. So if I were to divide both sides by sine squared theta, okay, so this is what I would see from the original identity. So there would be sine squared theta over sine squared theta, but on the second fraction, it will become cosine squared theta over sine squared theta. And then on the other side, I'm going to get 1 over sine squared theta. Now, this is the reason why it was important for us to go over all the reciprocal and the ratio identities before we started this lesson. We all know, well, if I were to simplify this, we know sine squared theta over sine squared theta becomes 1. Now, cosine squared theta over sine squared theta, according to the exponential property that we just observed on the previous video, can be rewritten as cosine theta squared okay, so this becomes cosine theta squared. We talked about this, okay, over, hold on, sine theta, the whole quantity squared. Okay, now over this side, when you have 1 over sine squared theta, well, guys, what is 1 over sine theta equal to? Well, that's the reciprocal of sine, which we know to be, you guessed it, cosecant theta. So on this side of the equation, what I should see is I should see cosecant square theta, which is from 1 over sine squared theta. Okay. Now, this is 1. Cosine theta over sine theta. Now, what does that ratio give me? What is cosine theta over sine theta? Well, if you remember correctly, that is the opposite or a reciprocal of sine theta over cosine theta, which gives me tangent theta. So cosine theta over sine theta must be cotangent theta. So here is my second Pythagorean identity, which is 1 plus cotangent squared theta equals to cosecant squared theta, which comes from the original Pythagorean identity, sine squared theta plus cosine squared theta equals to 1. Okay, we're going to pause here. I want you guys to take a minute and think about what this all means. Okay, take a minute, start copying this down to your notes, and I'm going to go ahead and recopy this again because there is a third one and we got to figure out what that third one is. So again, sine squared theta plus cosine squared theta equals to 1 is considered to be, well, we nicknamed it the mother of the Pythagorean identity because the other two basically is a algebraic manipulation that we do from this original one. Now, So by dividing both sides by sine squared theta, I was able to derive the second one, which is 1 plus cotangent squared theta equals to cosecant squared theta. So that is if we divide both sides by sine squared theta. So the other question you're going to have to ask yourself at this point is, what would happen instead of dividing by sine squared theta, I divide both sides by, you guessed it, cosine squared theta. Okay, so I'm going to do that right now. So let's see. Ooh, my square went away. Okay, hold on. Okay, so if we remember if we remember our reciprocal and ratio identities, okay, so sine squared, retype this backspace. Okay, so sine squared theta over cosine squared theta, again, this could be written as sine theta, the whole quantity squared, over cosine theta, the whole quantity squared, plus 1 equals to cosine squared theta. Now, what is sine theta over cosine theta? That's right, that is actually tangent theta. So the first fraction actually becomes tangent squared theta. The plus 1 stays. What is 1 over cosine squared theta? Well, that's the reciprocal of cosine theta. 1 over cosine theta is the reciprocal of cosine theta, which we call secant squared theta. Okay, so here we were able to derive 2 more Pythagorean identities. 1 plus cotangent squared theta equals to cosecant squared theta. Tangent squared theta plus 1 equals to secant squared theta. Okay, you are expected to know all 3 Pythagorean identities. I would like for you guys to have this memorized by heart. Now, the last thing I want to go over before we finish up this video is, I know this might start being a misconception somewhere, so we're just going to talk about this right now. On the previous question, I told you guys that sine theta squared is equivalent to sine squared theta. Okay, that notation wise, that is equivalent. Okay, now what they're not equivalent to, and this is important, I'm going to put a not equal sign to here, is it's not equivalent to oops, runaway slide again. Okay, sine theta squared. Because in terms of order of operation, okay, when you have something like this, you say, I'm going to evaluate the sine theta first, and I'm going to take that ratio and square the answer, which this is another way to write this. This still means sine theta times sine theta, which is the same thing here. But in terms of order of operation, when you have something like this without a parenthesis, what you're doing is you're going to take the actual angle, square that first, and then take the sine of it. So where these two are interchangeable in terms of notation, you cannot write this in places of these two. That will be incorrect. So please make sure you guys do know the difference between the three. And for the rest of the PowerPoint, because I do need room to work, so I'm going to be doing that probably on the whiteboard and filming myself, and I'll post up the the video for those tomorrow. So for tonight, I need you to familiarize yourself with the reciprocal and the ratio identity. Also understand where the Pythagorean identity comes from. Because again, guys, the important thing in the class is that you understand what you're doing. I don't need you to memorize the step. I need you to understand. Okay? All right. So look for my videos tomorrow. There should be another 2 videos to finish up the notes. And again, other than homework number 36, that's the only homework assignment I'm going to provide to you guys this week. And I'll post the solutions this weekend. Okay, thank you.